This is video 1.9.1, and the goal is to be able to find the distance and midpoint of 2 points and to know the standard form for the equation of a circle. So the first distance formula, I'm not just going to give it to you, I'm going to kind of show you where it comes from. It's going to help you memorize it a little bit better if you understand where it comes from. So the distance formula has to do, first of all, we're talking about 2 points. So I'm going to draw a random sketch of 2 points, x1, y1, and another point, x2, y2. And we're going to talk about how to find the distance between these 2 points, or really the length of this line from one point to the next. Now the way we're going to do that is we're going to think of this as a right triangle. Because with right triangles, I have methods to finding the lengths of the sides of the right triangle. The second reason I'm going to do right triangles is because, remember, the x and the y talk about how far left and right, and then how far up and down you are. So this distance along the bottom, from here to the right angle, I actually can find that distance. So let's do it for instance. For instance, if I had this x value was -5 for the x value, comma something, doesn't really matter, and the other x value was positive 22, the distance from here to here would be the difference between them, because I went 22 to the right and 5 to the left, but if I simply do 22 minus -5, I would get 27, which is the length of this side. So in general, to find the length of that side, you find the difference between the two x values. And that works if they're positive or if they're negative. So the length there is going to always be found by doing x2 minus x1, finding the difference between the two sides. The vertical side, the y, let's do another for instance. Let's say the x value, the y value for the lower point, let's say this y value was 4. And the y value over here was 15. Again, I would still take the difference because I want to know, okay, I started down here at 4 and I went up to 15. So that's really a difference of 11. And that's the distance from the bottom of the right triangle to the top of this triangle. So again, the distance here is going to be y2 minus y1. So that's going to work for no matter where I draw these points. In general, that will always work. So we have a description of the lengths of the sides of this right triangle. But remember, our ultimate goal was actually to find the distance between the 2 points, or the hypotenuse of this triangle. Well, going back to geometry, it's Pythagorean theorem. And with Pythagorean theorem, we always do a squared plus b squared equals c squared. So I'm going to write that down to remember. Now, in our case, we know that A is x2 minus x1. So I'm going to do x2 minus x1, the difference of the x's, and square them. Plus, now b squared, well, b is y2 minus y1. So y2 minus y1 squared. That equals the distance that I'm looking for, squared. That equals d squared. We're calling that d for distance, the distance between the points. So this is actually your formula, your distance formula. But math people, they go even one step further, just because in the end you're going to have to do one more step. And they write it as the square root of the difference of the x's squared and the difference of the y squareds. Because remember, if I actually want to find d down here, I would have to square root both sides to solve for d. So that's your formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That is your distance formula. So it's quite simple. That's the derivation of it. So be prepared to to kind of understand where it comes from. Now, midpoint formula. This is also going to be a very duh one. It should make sense. When we're given 2 points again, so again, if I was given the exact same points that I was given above, just some random points, and this is x1, y1, and we have x2, y2. And now instead of finding the distance between them, I actually want to find the midpoint. So if I were to draw a line, I'm looking for that point that's right in the middle. And what's interesting about this is you can also kind of think of these as right triangles. And I'm actually looking for a right triangle that's half the size. So I want to walk halfway to that point. If I'm trying to find the middle, what we normally do is we do what we call averaging, and we're going to do the same thing here. So again, we're trying to find a middle point, and we are going to average just like you do in regular numbers. But now we're averaging points. So we're finding the average. We're finding the middle. So we're going to add the x's and divide by 2 to find the x value for the midpoint, and we'll add the y's and divide by 2 to find the middle value for the y values. None of this should be completely new. It should be something you saw in geometry, but it's been a while. So you'll want to get these formulas memorized, and we'll use them to help us make sense of the next conic sections. So let's try this out as a problem. So we have to find the distance and midpoint between these points. So using the distance formula, it says the square root of the x's squared, the difference of them, of course, and the square root of, and add the square of the y's squared, the difference of the y's squared. So we're going to subtract the x's, 3 minus negative 1, and square it. And then we're also going to subtract the y's, negative 2 minus 4. Now notice I use the second point first, so I use the second point first in both of my differences. It is good to be consistent because this sometimes matters when we are working with different formulas. In this case, it honestly doesn't. And if you can explain why, then you don't have to worry about keeping order matters. But there is a reason why it doesn't matter in this case, but to be safe, we're going to follow the formula as written. So we have square root of 4 squared plus negative 6 squared. So it looks like we're going to get 16 plus 36, which is 52. I want to check for some simplification, and I know 52 is 2 times 26, which is 2 times 13. 13 is prime, so I'm done. So that means that since there's a pair of 2's, this equals 2 square roots of 13. So that's my simplified distance answer, is 2 square roots of 13. Now I want to find the midpoint. So for midpoint, I'm going to find the midpoint by averaging the x's and averaging the y's. So again, I'm going to go back up to my formula, and I'm going to average the x's. So it's going to be negative 1 plus 3 divided by 2. And I'm going to average the y's. So 4 plus negative 2 divided by 2. So this point will give me, the first one will give me 2 divided by 2, which is 1. And the next one will give me 2 divided by 2, which is also 1. Now think carefully, is that number in the middle? Is that point going to be in the middle? You should be able to draw a nice straight line if you were to plot these 3 points. But yes, 1 is right in the middle of each of these sets of numbers. It is exactly in the middle. So there's your midpoint. So we'll say it equals m, and there's the distance. There you go. It's that simple. Now, how does this help us explain circles? So here's the number one definition that most math students don't know, even when they get to pre-calculus. They don't know the definition of a circle. You will be tested on the definition, so be prepared to understand and know each of the definitions for the conic sections. A circle is the set of all points in a plane that are equidistant from a fixed point. That's a simple definition. It's not a line, it's not a curve. The mathematical definition is a set of all points in a plane that are equidistant from a fixed point. So understanding the picture and how you draw it, the fixed point, of course, is the center of our circle, and we find a ton of points, an infinite number of points that are equidistant, and that happens to be the radius. That's the distance. So that will be how we would sketch our circle. We find all those points that are equidistant, and we have a circle, better drawn than mine, hopefully, a circle that we love and know since we were young. But that's the definition. So in our case, we're going to be graphing them in the coordinate plane. So we're going to have center h comma k. It's just the center we're going to use. You've seen h and k before. It's a key point in a graph. And the collection of points will be all the points x comma y that are a distance of r away from that center. So what's interesting is the distance formula actually helps explain the equation for this. So we're going to describe all points that are equidistant from a fixed point. So no matter which point x, y I pick on here, I want to have the same distance r. So the way I write the rule is by using the distance formula, but I'm going to go back to distance squared x2 minus x1 squared and y2 minus y1 squared. I'm going to use this formula and I'm going to show you how we get the equation for a circle from this formula. So now what we have is x2 minus x1 squared. Well, in our case, one of our points is hk and the other one is xy. So our formula is going to be x minus h squared, because that's the difference between the x's, x and h, plus the difference of the y squared. So I've got to keep the same point first, y minus k squared. So now it's y minus k. And that equals the radius squared, because we want the distance to stay r. And that is where the equation for a circle comes in. It's truly just the Pythagorean theorem describing all those points x comma y that are the distance of r from h comma k, the center of the circle. So that's the equation of a circle. Now what we're going to do is we're going to use that equation to graph things. So and to write equations as well. So example number 2 here, so this is your notes that you'll want to write down. Number 2 is write the equation of a circle with a center 0, 0 and a radius of 2. Well, looking at our notes up above, if the center is 0, 0, then that's hk, and the radius is 2, well, that's r. So I'm going to just plug those 3 numbers into my equation. It's going to be x minus 0 squared plus y minus 0 squared equals 2 squared. I simply plugged in what I knew, 0, 0, and the radius. And I have my equation. You can leave it as 2 squared. You could also write it as 4. You could get rid of the zeros because they don't really matter. Another way to write this is x squared plus y squared equals 4. That's a sort of simpler way to write it. Both answers will be acceptable. So now going backwards, if we were, I'm not going backwards, but now we're being asked to graph this circle. We're going to first notice the important information, and remember our standard form is x minus h squared, y minus k squared equals r squared. So if I'm trying to find the key values, I'm looking for h, which in this case h is 2. I'm looking for k, which in our case is negative 4, because it should be y minus k, and we got y plus 4. And I'm looking for the radius, which in our case is 3, because 9 can be written as 3 squared. The radius will always be positive. Yes, negative 3 also gives you a square of 9, but we're going to have a radius be a positive distance. So this means that my center is at 2 comma negative 4, because that's what h and k stand for, and the radius is 3. So I'm going to start by going to 2, negative 4, and plotting the center. And I'm going to use the radius to find some more points so I can draw a sketch in a circle. So I'm going to go 3 away in all directions. So I'm going to plot 3 away in all 4 directions. Because those are 4 points I can quickly sketch because the radius is 3. Now I'm just going to sketch in a nice curve to connect them, to show my circle. And again, hopefully you're a better sketcher than I am. There's your circle, and you're done. So on a test, I'll be looking for key points like, did you graph those 4 so I can tell what your radius is, and did you plot the center? And then you'll get your full points. That's a circle. Now in class, we'll be learning a little bit more in the next video about some harder problems when the equation isn't written as nice, and we'll worry about that later. Here's your checkpoints. They are multiple choice, which will allow you to answer the form, the Google form online with ease. So make sure you try these problems and submit your answers online before you come to class.